The prelim paper of physical science. We look at question 3. We read question 3. A 50-gram ball is dropped from a certain height. The velocity time graph below represents the motion of the ball as it bounces vertically on a concrete floor. The time of contact during the bounce is 0.02 seconds. Ignore all effects of air friction. So here's a diagram, interesting diagram where an object is dropped. It hits the floor. The time of contact with the floor is 0.02 seconds. It bounces. It reaches maximum height and goes back down towards the floor. Alright, so the first question is define a projectile. Now, usually these questions, always the first questions are definitions. So what's important is that you should not lose marks with definitions. Question 3. So 3.1. The question is define a projectile, and we can say a projectile is a moving body where the only force acting on the object where the only force acting on the object is the force of gravity. What I want to emphasize here to you now is that you should not lose marks for definitions. Make a note of all the definitions that you have to learn before time and learn your definitions well, because definitions count a high percentage of the physical science paper, so you don't have to lose unnecessary marks. Alright, so that's 3.1. 3.2. Write down the magnitude of the velocity with which the ball leaves the ground after bouncing. So here now we must look at this diagram and we must see where is it that the ball hits the ground, when does it leave the ground. So here's the object, it is dropped, it hits the ground, it's in contact with the floor for 0.02 seconds, and then it leaves the ground, and the velocity at which it leaves the ground is 3.43. So the question is, write down the magnitude of the velocity. So let's write down the magnitude of the velocity. 3.2. Velocity is 3, is it 3, or it's 343? 3.43. 3.43, and its velocity, so we must put our units, meters per second. Okay, let's go on. 3.3. Draw a labeled free body diagram showing all the forces acting on the ball at 0.7 seconds. 7 seconds. So if 0.77 seconds, we've mentioned that this is where the ball leaves the ground and then it goes up, and this is where it reaches maximum height and then it goes back down. So 0.7 seconds is when it reaches maximum height. So what are the forces acting on it when it reaches maximum height? So the forces acting on it will be the force of gravity. So we'll have to write that down, 3.3. Excuse me. 3.3. So then here's your forces acting down, and the only forces acting on it is the gravitational force over. So that's the way to do 3.3's answer. 3.4. If you look at the question, 3.4 says, use the information given on the graph to calculate the acceleration of the ball. Right, so now how do we calculate the acceleration of the ball? Use the information given on the graph. So we can do this by working out the gradient on the graph, or we can use equations of motion, right? So if you're looking at the graph itself, if it says using the information given on the graph, see that the initial velocity is 0 and the final velocity is 3,92, and the time for it to reach that speed is 0,4 seconds. So if you work it out, we can write down the gradient. If you look at the gradient of this graph from this point to 3,92, let's just write it down, 3.4. So you can say the gradient of the graph will be equals to delta y over delta x. So delta y over delta x, or delta y will be 3,92 minus 0, and your change in x will be the time taken for the change will be 0,4 minus 0, 0,4, right? We'll write it down. And that will be equal to 0,4, and if you work that out, let's see, if you work it out, you can say 3,92 divided by 0,4. Let's take our calculator, and then it's 3,92 divided by 0,4. So that gives you 9,8 meters per second squared. So that will be the gravity using the gradient on the graph. However, if we don't want to use the gradient on the graph, we can use equations of motion. We can say Vf is equals to Vi plus A delta t. And your final velocity is 3,92. Your initial velocity is 0. Plus you're working out your acceleration due to gravity, and your time of contact, or your time that it was on the ground was 0,4 seconds. 0,4 seconds. And if you work that out, you'll see that if you work out your acceleration using this method, our acceleration will be 3,92. This is an acceleration, right? 3,92 divided by 0,4, and then you get 9,8 meters per second squared. So we see we get it in two ways. Okay, going on to the next question, 3.4. The height from which the ball was dropped. So if you look at the height from which the ball was dropped, again here, the height, if you're working out the height of velocity time graph, then you'll use the area under the graph, right? So it will be the area under this graph, it will be this triangle. So if you work out the area of the triangle, we can work it out. Let's just put this down. So that will be equals to the half of your base times your height. And if you look at this case, the half is there, your base. If look at your base of the triangle. It will be 0, 4, and your height will be 3,92. From here to here will be 3,92, and your base will be there from 0 to 0, 4. And if you take your calculator and you work it out, let's say 0.5 times 0, 4 times 3,92, and you get 0, 0,78 meters. So that's one way of doing it, by working out the area below the graph. The other way, as we did in the previous sum, is to use equations of motion. So if you're using equations of motion, then we'll have to see what values we have. And in our case, we'll say Vf squared. We got final velocities 3,92. Vf squared is equals to Vi squared, which is 0, plus 2 acceleration, which is gravity, times time. So your final velocity is 3,92 is equals to your initial velocity, which is 0 plus 2 times 9,8, which is gravity. Vf squared is Vf squared plus 2 as, not g. This is not right. This is Vf squared plus 2as 2ay. Let's just fix that up. Study areas which we cannot accept under any circumstances. 2gs, and then you have to work out the displacement. Alright, and if you work that out, so 3,92 minus 19,6 will give you S. Well, actually not S, I'm looking at the old system, sorry. 2G, not S, it will be Y. 2 and then if you say 3,92 minus 2 times 19,6, so you can say your Y will be 0,78. Silly errors because of rustiness for the equation. 3.4.2. Alright, going on. 3.4.2, 3.5. On a set of axes, draw a position time graph for the motion of the ball from 0 to 1,2 seconds. Use the ground as a zero reference, indicate the height from which the ball was dropped, and all the time on the t-axis of your graph. So you need the time on the t-axis on your graph. Right, so then we see that this object was dropped. So we'll have to put these values on 0, 0,4, 0, 0,42, 0, 0,77, 1,12. Okay, now this is going to be a challenge for me to draw it. Let's take a chance. 2.5.